So what we're going to do, we're going to talk, it's basically everything you already know. I'm not going to teach anything new. I mean, it's stuff that, it's all this graphing. We're just continuing the graphing. The only difference is, well, first of all, let's just talk, we're going to talk about graphing. This is our title. Graphing systems of equations and inequalities. And maybe I'm going too fast, but we'll just try it. I think you guys know this. It's not anything new. But basically, up to this point, I've been giving you one equation, right? I said, graph this, something like this. Graph y is equal to 1/2 x plus 2. And since this is written in slope-intercept form, right? Slope-intercept form, you just went up to 2, you did your y-intercept, which is 2, put a dot there, and you use your slope. You rise 1, and you run 2, right? So I'm going to rise 1 and run 2, and put a dot, and then I draw my line, okay? Okay, so last year you guys learned systems. What's a system? You guys remember? It's more than one equation. So if I had two equations and I asked you to graph those two equations on the same graph and find where they intersect, find that point, right? Remember those? Remember that, Oliver? Right? So that's what it is. That's systems of equations, just like a stereo system, right? Is a stereo system just a chord? Right? No, it isn't. What else? It's also, you gotta have your DVD player, right? You gotta have your big screen television, flat screen, right? You gotta have your, your controller, your remote control. It's lots of things. So systems in math means more than one. Does that make sense? So instead of graphing just equations, we're going to talk about graphing systems of equations, and you're actually finding those points where they intersect, okay? So let's say I said graph this equation, get rid of that right over run so it doesn't look confusing, and this equation. So y is equal to negative 2x plus 1. All right, so I'm going to go up 1, put a dot, and what is it? Negative down 2, 1, 2, over 1, put a dot, and I'm going to draw this line, boom. This point right here, which is, unfortunately, I don't know what the answer to that one is, because see, it's sort of going to be a fraction. It's over like a third maybe, 1/3 up 1 2/3 or something like that. I would have to guess. I don't know, but I can at least visually see where they intersect. Does that make sense? Right? And the goal with these, on the ones on the homework tonight, you'll be able to, if you're really careful, you have to be very, very, very precise when you graph these. I would even recommend using a ruler, because you want to be sure that you know exactly where that point is. You don't want to be an approximate point. You want it to be exact. That's the only way solving systems of equations works by graphing, is by being precise. Does that make sense? Because if you're messy, I mean, if I just drew it like this, oops, that didn't work, like that, then my point would be here, right? And I don't know, maybe it's here, maybe it's here, maybe it's here, maybe it's here, maybe it's here. I got to be precise, so I know exactly where that point is. And ideally, on a graph grid, ideally, they're going to land right on a corner, something like that, right? And I'll know, oh, it's right there. It's this point right here. Yeah, so it's right there. So that is over 1, whatever. So you can tell me the answer, right? But anyways, so graphing systems of equations is just taking the two equations and graphing them on the same graph. And then just looking at seeing where they cross. That's all. Easy. Make sense? sure?
Yeah.
You guys get it, right? So I don't really have, you already know how to do this, right? The only one I want to practice is the systems of inequalities. So you all understand systems could be 2 equations, it could be 3 equations, it could be 4 equations, it could be 5 equations. Very seldom you're going to see more than 3, but you won't see, with me you're only going to see two equations. All right, but when you move into algebra 2 in a few years, or a couple years probably, then you will actually be doing at least, well, you'll be doing 3, sometimes more, sometimes 4 equations. Now, okay, so now let's say I asked you to graph systems of inequalities. Inequalities meaning greater than or less than, right? Systems means more than one of them. That's where they get a little more complicated, because you're using the same graph. And remember, with inequalities, you know how you have that shading, right? It's easy for that shading to get confusing when you have 2 lines, right? So it's really helpful if you use 2 different colors. And maybe I will do that actually today. And then we'll just do one, and then I'm going to try to just one for the lecture, and then we use these. Okay, so let's say I said graph, actually let me just use the colors for the equation. So y is greater than 2x minus 5, and y is less than or equal to 1/2 x minus 3. I don't know, I'm just making this up. Okay, whoops, but I wanted to do that one in green. Y is less than or equal to 1/2 x minus 3. Okay, so here's my graph. Did you guys do these last year? Systems of inequalities? So it's just a matter of using 2 different colors, right? So 1, 2, 3, 4, 5, 6, 7. We'll just get a few lines here so that we can do this kind of quickly. Okay. So what would I do for the first one?
You would start at -5.
-5. So 1, 2, 3, 4, 5. Put a dot.
And then you'll go up 2 over.
Up 2 over 1. Put a dot. And so now I can draw that, right?
Yeah.
So now, am I going to draw a solid line or a dotted line?
A dotted line, because it's not equal.
Does everybody agree with that? Do you agree with that, Oliver?
Mm-hmm.
Dotted line? Okay. Dotted line. Okay, and I put little arrows on the end because it means it goes on forever. Now, the question is, where do I shade? How do I know where to shade?
You multiply
I do what?
Go towards the 0. Yeah.
Okay, so I'm going to try. Let me just try what 0, 0 would be. 0, I'm going to plug, 0, 0 means my x is 0 and my y is 0. So I'm going to plug those in. 0 is greater than 0 minus 5. Is 0 greater than 5, -5?
Yeah.
Yeah, it is. Okay, so therefore that is a solution. Therefore everything on this side is a solution. So I'm going to shade this way, right? So that's my shape. Great. So I have that all figured out. Okay, now I am going to graph this one. How would I graph it? Una, help me with this one. So I want to be sure you know how to do these. Okay, -3. There we go. Up 1. Over 2. About there. Okay. Okay, up 1 over 2. Good. And then, is it going to be a solid line or a dotted line? It's going to be dotted if it's only greater than or less than. But see how that line, there's a line underneath? That line means also equals. So that's less than or equal to. Does that make sense? So that means if it's equal to, I can make it a solid line. You get that? Okay? So I'm going to make that a solid line. Okay, there's there's my thing. Now I gotta figure out how to shade it. So Una, how would I shade it? How would I figure it out? You choose your easy point on the graph. 0, 0, right? And plug it in. 0 is less than or equal to 0 minus 3. I don't need to write the 0 minus 3, I just write the minus 3. Is 0 less than or equal to negative 3?
No.
No. Therefore, this is not a solution. Therefore, I have to, all the solutions are on the other side of the line, right? So then I am going to start shading like this. Now, where's my solution? It's, remember, a solution, remember with systems of equations, it's where they both share the same point, right? They both share that same point. With an inequalities, systems of inequalities, where do they both share the same points? An infinite number of points. What? So, see, can you see where they're shaded, where they're both shaded together?
Oh, yeah.
Where they have the cross shading? This, see this little triangle here?
Yeah.
Right there, you have both the red shading and the green shading. That's your answer. All of this, it's an infinite number of answers, but it's that little thing. So I might, once I realize where the answer is, I might make it a little more obvious. Like I might keep going like this. I know it's going to be like this. This is going to keep going. And so I know it's that, and I know it's this, right? So this is my answer. It's this little triangle here where they're both the shading touches each other. Does that make sense? Okay, so fist of 5, you get it? Can I put some on the board? And why don't we do it in groups of 2? Does that work?
Yep.
So that you guys can work together on it? All right, so I'm going to just turn this off.